Ratios or rates of two quantities are equal or consistent, then the quantities are considered proportional. If the ratios or rates of two quantities are not equal, then the quantities are non-proportional. Okay? So if they are equal, so you set up your ratios just like we've been doing, and we see, are they equal, are they not equal when they're divided. Okay, for example, Eric and Lucy ran 20 minutes each on the treadmill at the gym. The table below shows the number of calories each has burned after 5-minute intervals. Complete each table to determine the type of relationship. So you can see here, for Eric's run, after 5 minutes, he had burned 70 calories. 10 minutes was 140. 15 minutes was 210. 20 minutes was 280. So we're going to set these up as rates, calories per minute. So calories is going to go in the numerator. Minutes is going to go in the denominator. So 70 over 5, or 70 divided by 5. I don't have my calculator up here, so somebody divide that or use your mental math. 14 calories per minute. 14 calories per minute. Let's set up the second one. Again, calories per minute tells us that calories goes in the numerator, minutes goes in the denominator. 140 divided by 10 is what? 14, and then it's calories per minute. Are we proportional so far? Okay, let's keep going. 210 divided by 15. Is it 14? So 14 calories per minute. And then the last one, we've got 280 over 20. Someone divide that and tell me what you get. 14 calories per minute. So since the calories burned per minute is all 14 calories per minute, since all of the ratios simplified to the same unit rate, then we would say that it is proportional. The calories burned by Eric is proportional to the time because the unit rates are all equal. The unit rates are all equal. And you could put 14 calories per minute. They're all equal to that 14 calories per minute. So his calorie burn stayed consistent the entire time he worked out. Yes, ma'am. Huh? Eric? Yeah, this is Eric's table. I didn't hear what you said. I'm sorry. Are you sure? Okay. Sorry, I can't hear anything. My ears are clogged too. All right, so let's check if Lucy's rate was proportional. Okay, so again, we're going to do calories per minute. So we have, in this first section, we've got 45 over 5 calories over time. So what does that divide to equal, Madeline? 9 what? Calories per minute. Okay, let's check all of them, because if even one of them is not the same, then it's not proportional. What's 90 divided, oh sorry, that should be a 10, not a 5. What's 90 divided by 10? Anybody? Jack? 9. Again, 9 calories per minute. Okay, the third one, we've got 120 over 15. What does that divide to equal? All right, so right there, that 1 5-minute interval where she burned only 8 calories per minute on average, that tells us that it's not proportional, okay? Even though the rest of them so far have been. What's 180 over 20 equal? Okay, so the only one that's different is that 15-minute increment. She burned just a little bit less calories. Maybe she lowered the intensity on the treadmill. Maybe she had to walk a little bit. Okay, but because of that one section, the calories burned by Lucy is non-proportional to the time because the unit rates are not all equal. So as you're going through each table, you do have to divide each and every category, each and every column or table, okay? Because if even one is off, then it throws the rest of the proportion off. Okay? Something going on that I'm not noticing.
Yeah. Spell R like a pilot.
R. Thank you. Okay? So if even one column or row in your table is off, then the whole thing is off and it's not proportional. Okay? All right, take a minute. Determine whether the quantities in each of these tables are proportional. If yes, give the constant rate. Give that unit rate. Okay? All right, guys, let's go over number 1 and 2. So on number 1, you're determining whether the number of buses is proportional to the number of students in every single row. Okay? So when you set up your division problem, what number did you put in the top? Did you put the number of buses or the number of students? Jack? Why did you put the number of students in the top? Okay, so if you think about it and say them out loud or say them in your head, buses per student doesn't really make a whole lot of sense, does it? How many buses would we need for each one student? That's not very logical. But if we flip it around and we say how many students would be on each bus, that makes more sense. So that right there tells us the order. So we're going to take our number of students and divide it by the number of buses. So basically you're flipping these upside down. 24 over 1 is just 24. So in this first column we'd have 24 students per bus. Okay. What about this next one? 45 divided by 2. What's 45 divided by 2? Max? All right, so that right there tells us what? Not proportional. Since these don't match, we're done. We don't have to do any more. So this is non-proportional. So as you're going through your homework today, if you find even one that doesn't match, you don't have to do the rest. You can stop and say it's non-proportional. Okay, number 2. Which one would go in the numerator on this one? Hours worked or money earned? So think about this way. When you are being hired for a job, is it the hours worked per dollar? Or is it the money that you earn, the dollar amount per hour? Dollar amount per hour. So the money earned is going to go in the numerator. Hours worked is going to go in the denominator. So for this first column, 36 divided by 4. Audra, what's 36 divided by 4? Close. 9. So in this first column, this person earned $9 per hour. Excuse me. Okay, let's check the second column. 72 divided by 8. 72 divided by 8. Caroline, what do you get when you divide 72 divided by 8? You get 9 again. So $9 per hour. Are we proportional so far? Yes. Elena, next column, we have 10 hours worked, money earned was $90. So what would that unit rate be? 9 again. 9 what? What would your 9 hours? No, not 9 hours. They worked 10 hours. Help her out. 9 what? Turner? $9 per 1 hour worked. Okay, make sure you have the correct label on your notes. If you don't, add it in. Okay, fix your paper, hon. All right, this next one we've got is 15 hours worked, and they earned $135. What's that unit rate going to be?
$9 per hour.
$9 per hour again. So is this proportional? Would we say proportional or non-proportional? Proportional. And what is the constant rate? What's our constant rate, or what is the unit rate here? Caroline? $9 per hour. Good. Questions about those two? All right, I want you to work with your shoulder partner on 3 through 6. Yeah. All right, guys, let's go ahead and talk about these. So on number 3, we're talking about the number of movie tickets sold compared to the revenue. What does revenue mean? Money. Money what? Is it money spent, money brought in? Money made. It's the amount of money that the movie theater brings in. Okay. All right, so for 25 tickets, the revenue was $175. What is that as a unit rate per ticket? PT? 7? Do you all agree? All right, so $7 per ticket. Okay? So now let's check to see if they all are equal to $7 per ticket. What do you think?
The next one is 6.45, which makes it non-proportional.
All right, so did you divide, what'd you divide?
I did 260 divided by 38.
260 divided by 38. Do you all agree with that?
Yeah.
All right, so what was the dollar amount again? 6.8. So since it's money, we need to add the 0. 0.84. And did you round it to the 0.84? Okay, per ticket. So that right there tells us is non-proportional. Non-proportional. Okay, number 4. So you've probably heard the phrase miles per gallon, right? All right, so for miles per gallon, the first one's obvious, 21 miles per gallon. And you can see, you've seen this abbreviated as MPG. Okay, you could also write miles/gallon, miles per gallon that way. Okay, the second one, we've got 2 gallons for 42 miles. What is that as a unit rate? Seems like we've got the same 2 people participating in class today. Landon?
It is 21.
That one's 21 again. All right, 3 gallons to 63 miles. Audra? 21 again. 4 gallons for 84 miles. Sophia? 21. All right, so is this proportional? Yes, so we say it's proportional. And this car gets a consistent 21 miles per gallon. Okay, number 5, proportional or non-proportional? Proportional. What is the cost per candy bar? Bailey? $1.25. Did you divide candy bars divided by cost? So you figured out the amount of candy bar you get per dollar spent. But when we're setting up unit rate with money, money always goes in the numerator. So we want to actually divide 4 over 5, 8 over 10, 16 over 20, 28 over 35. Okay, what'd you get? 80 cents per candy bar. They all equal that 0.8. Okay, so that is proportional. Okay, and the last one, we're looking at songs per minute or minutes per song. Minutes per song. Minutes in the numerator, songs in the denominator. All right, what did you get?
This one is not proportional.
Which one throws it off?
The second.
The second one. What'd you get for the first one? 4 minutes per song. Okay, make sure we're putting a label with each of these. 4 minutes per song. Okay, and in the second one, what do you get?
I got 3.75.
Do you all agree? 3.75 minutes per song. So since that second one is different than the first, we can stop and we say it is non-proportional. All right, so questions on determining whether it's proportional or not. Typically, when you have a table, the second row tends to be what you put in the numerator, and then the first row tends to be what you put in the denominator. So it's kind of backwards from what the table displays. You just kind of flip them over to divide. All right, so we can also use this information to complete a table. We're just going to reverse what we were doing. So instead of dividing, what do you think we're going to be doing? Multiplying. So assuming that the following tables represent a proportional relationship, complete the table. So on number 7, it says that Ben earns $8.50 per hour bagging groceries at the grocery store. We want to know how much money he would make if he worked for 4 hours, 8 hours, 10 hours, or 14 hours. All right, so how do we find out how much money he would earn in 4 hours if he gets $8.50 per hour? Landon, what do you think?
You multiply $8.50 by 4.
All right, take your hourly rate multiply it times the number of hours worked. Have you already multiplied that? What do you get?
34.
Do you all agree? 850 times 4 is 34. Okay. So then what would he earn if he worked 8 hours? Sophia? Good. 68. How about 10 hours?
85.
And 14 hours, PT?
114, which means 190. Yeah, 119, which means that
$119. All right. So we're assuming that these are proportional relationships. Now we know that sometimes you can get overtime if you work more than 8 hours in a day. So that would make it non-proportional. But in this case, we're assuming it's just that same constant rate, $8.50 per hour. Okay, number 8. The wide receiver can run 9 yards per second. So after 1 second, how many yards has he ran? That one's just the unit rate, 9. Okay, how about after 3 seconds? How many yards would he have run if he stays at that constant rate? Jack? 27 yards. Okay, what about after 6 seconds? Audra, how many yards would he have run? 54. And after 10 seconds, how many yards would he have run? Bailey? 90 yards. Now, is it logical to say he would run at the exact same pace the entire time? For a short amount of time, sure. But would he be able to keep that same speed if he were to run for 30 seconds or 60 seconds? No, you tend to slow down the longer that you run, especially if you're sprinting, right? You get tired. So as that time gets longer, the speed might slow down a little bit, and we might start to notice that it's not proportional anymore, okay? But at the beginning here, sure, it might be very logical that he can keep that same speed of 9 yards per second and stay proportional. Okay? I want you to try 9 and 10 on your own, and then as soon as you're done with those two, you can use the rest of class to work on your homework with a partner.